or the surface of the moon. Our guide is Dr. C.H. Clemenshaw, director of Griffith Observatory. He has invited us to join him and his companion, Mr. Art Baker, on this adventure in science. By means of modern photography and high-powered telescopes, we can take what appears to be a real trip to the moon. So fasten your seatbelts, sit back and relax, as Dr. Clemenshaw describes our trip.
Here on the instrument panel is a map of the moon and a guidance device that will chart our course over the surface when we arrive. Also, we'll be using this down viewer to see the terrain that passes beneath us. You will note that features of the map are recognizable with features on the real moon.
How clear it is.
Yes, Art, we are well beyond any trace of the Earth's atmosphere. The moon is only about 1/4 the size of the Earth and has no atmosphere, so there is nothing to obstruct our view.
So, Doctor, you said that the moon was smaller than the Earth. Now, what has that to do with it having no atmosphere?
Its gravity is only about 1/6 as much as that of the Earth. You probably know that by the word atmosphere, we mean a layer of gases that surrounds our Earth or some other celestial body. These are made up of fast-moving molecules. The moon is too small to have enough gravity to hold on to them, so it has no atmosphere at all.
But without atmosphere, I imagine it'd be pretty uncomfortable on the surface.
Yes, the air on the Earth keeps out some of the sun's heat. But on the moon, without that protection, the temperature gets up to about 200 degrees. The air on the Earth at night is like a blanket holding the heat in. But on the moon, the temperature drops to 250 degrees below zero.
Doctor, without protection of atmosphere, the moon gets to 200 degrees above zero in the day and 250 degrees below zero at night?
That's right. This eerie land we are approaching is a dead world without air, without water.
Well, speaking of water, Doctor, haven't I heard those dark areas spoken of as seas?
Yes, that's what early astronomers thought they were. They called them Maria, the Latin word for seas, and they gave them names that we still use today. The one to the far right is called Mare Crisium, Sea of Crises. Immediately to its left is Mare Tranquillitatis. Above it is Mare Serenitatis, Sea of Serenity. This is the area in which man's first successful moon missile is reported to have landed. At the top of the moon is the North Pole. That perhaps is why the area directly below was called the Sea of Cold, or Mare. Of course, these Maria cannot be oceans, for there is no water. They are plains, probably similar to great lava beds we know. Filling the upper part of our windshield now is Mare Imbrium. Remember some of these names if you can. Mare Imbrium. It is often visible to the naked eye from the Earth. Our first excursion will be a flight around its shores. We're heading for the mighty crater Copernicus, which will serve as a reference point for our explorations. It is about 70 times as large as the enormous meteorite crater in Arizona. We're not sure what formed each of the craters of the moon, but Copernicus certainly gives the appearance of having been caused by an explosion, and could well have been formed by the impact of a meteorite, or even a small planet.
I wonder how big a dent we would make. Huh?
Well, perhaps we could make a good-sized crater at this speed. There we've leveled off and are traveling north across Mare Imbrium. You will notice that our path is being charted on the map. We're around Mare Imbrium and back to Copernicus. Straight north in front of us is the Bay of Rainbows.
It certainly doesn't look like any bay I've ever seen on Earth.
Well, it isn't. Its surface seems to be a flat lava bed, and there couldn't be any rainbows here, for there is no rain. Moving along the shoreline, we see what would appear to be offshore islands. Now we come to one of the most studied craters on the moon, Plato. Some astronomers believe that there is a fog visible at sunset and sunrise on the floor of Plato. It is mid-morning now, so we're unable to see it.
Now, how can a fog exist if there's no atmosphere?
Well, if it does exist, it is probably formed by gases escaping from old volcanoes. As you can see, the moon has mountain ranges, as we do on the Earth. There are the Alps. And the Caucasus.
Sounds like those names were borrowed from the Earth.
That's right. Here, we can turn on the down viewer now.
Doctor, are we still over Mare?
Yes, we are.
It's difficult to think of this as an ocean with these big craters.
That's right, Art. A dark sea of rock and desolation. Well, we're now leaving the coastline and going over the Apennine mountain range. Some of these peaks reach an altitude of 20,000 feet, as high as any mountain on the North American continent. Now, if you will look far off to the right, you will see our reference point.
Doctor, I'll never forget it.
Well, it is a good one to remember and can be seen from back on Earth with nothing more than a pair of binoculars. We will follow the Apennines back to our old friend Copernicus, come to a complete stop, and hover directly over the crater. You have probably noticed how well the mountains and craters stand out when the sun is in such a position that they cast shadows. Such is the case with the crater Eratosthenes beneath us. But we're missing one of the moon's most brilliant displays when the sun is in this position. So as soon as we have stopped, I'm going to cause time to move forward and to bring the sun directly overhead. See how the shadows have faded as the sun moves overhead? The light areas are brightening to a glow. The whole scene has changed. Now we will move straight up to see the great blazing spread of these rays. When the sun is in this position, the lighter areas of the moon can best reflect light. This is particularly true of the ray systems of many of the explosion craters, such as Copernicus.
Well, that crater that we passed over a moment ago seems to have completely disappeared.
Eratosthenes. Yes, that's right.
Well, Doctor, what are these rays?
There are several theories on them. They could be dust and debris thrown out by an explosion, or they could be the result of cracks caused by the impact of meteorites. Gases could have seeped up from the cracks, condensed, and formed white powder on each side of the crack. But for a brilliant ray system, look to the far Tycho. Remember that name, Tycho. On Earth, it can be seen under good conditions at full moon with the naked eye. Its rays run for hundreds of miles. Imagine the explosion that must have formed it.
It almost gives the impression that an explosion is taking place right now. Could we get a closer look?
We will. To see it better, the sun at an angle that shadows are cast. So we'll drop to our position over. Move time forward, and we'll be off to the big crater country in the south. The rays are fading slowly, and the shadows reappear as the lunar day wears on. All right, go.
You've moved time forward pretty fast. What time is it now?
Well, where we are right now, it's late afternoon. On the moon, a day is about a month long. The sun rises and sets 2 weeks later, because the moon rotates on its axis only once a month. We are now passing over a fascinating old walled plain. This is Ptolemais. It's approximately 90 miles wide. The very smallest craters you can see on its floor are about the size of the meteorite crater in Arizona.
It appears to be rather than round.
Yes, that's right. The moon is probably composed of the same basic material as the Earth, but without an atmosphere to cause wind and water erosion. Its surface has remained virtually unchanged for countless centuries. This is called the Straight Wall. Actually, it is not a wall, but a cliff, and it is a big one, 800 feet high and 80 miles long. There must have been a great sinking of the moon's surface here at one time to have created this long, sheer cliff. Well, now for that closer look at Tycho I promised you. We'll make a climbing turn and make a direct approach to it. There, it's centered before us. With the sun in this position, the rays are barely visible. Nearer the horizon is the enormous Clavius. Here is a good example of the varying ages of the moon's crater-like formations. The smaller ones inside and on Clavius' rim were obviously created after it was.
That's wild and desolate land. Surface travel will be difficult down there.
Would you like to go down and land?
Well, yeah. Okay.
We have flown away from the portion of the moon that is lighted by the sun. But we won't be landing in darkness. The Earth reflects sunlight, and this is much brighter on the moon than moonlight is on the Earth. If we could step outside there and get on a scale, we'd find our weight only about 1/6 of what it is on Earth because of the lower force of gravity of the moon. But I wouldn't recommend a trip to the moon as a way to lose weight. The sun is just below the horizon there. There you see a peak that the sun's rays are just touching. Well, Art, it's time to start back home. Trip ahead of us. The average distance between the moon and the Earth is about 240,000 miles.
Say, that's home, isn't it?
Yes, that's Mother Earth. From this distance, it looks like a large ball hanging in space. Actually, it is traveling at a speed of 66,600 miles an hour in its orbit around the sun.
Do you think there are other Earths as beautiful and abundant with life as ours?
It is certainly possible. We may never know the answer to that question, but it is well to consider our blessings and at the same time give thought to our humble relationship to the vast realm of the universe. Such contemplation may make it easier for all of us to get along with our fellow passengers on this spaceship we call Earth.